WHOIS has been around for a long, long time. WHOIS is a lot less useful now due to GDPR, by the way. Here's what the SANS.org WHOIS lookup looked like now GDPR. What, Bank of America, British Airways, $180 million fine, was it? British Airways. Marriott, similar, like $90 million or something. Crazy, crazy. WHOIS looked like that a year ago. Alan Poller, Bethesda, Maryland, blah, blah, blah. Let's check it out today. What does it look like today? WHOIS, SANS.org. This is GDPR. This is the new European privacy regulation that has actual real teeth. GDPR, if you have a breach, they can fine you 4% of global income per breach. 4% of global income each breach. They hit British Airways and Marriott with 1.5% fine of global income. Both of them got hit, right? We're talking hundreds of millions of dollars. They're losing their minds in Europe, and it's driving actual real change. The problem with security up until then is, in most cases, it was cheaper to have a breach than prevent a breach. It was. It's been cheaper to have a breach than prevent a breach, so most companies, including my last company, would have the breach. My last company, the CIO would rather have the breach than prevent it. She's like, so the fine's like 30 grand, that's who you're talking about, is 200 grand, we'll pay the fine. I'm like, so that's been my 28 years of frustration in my career with that mindset. It's been driving me nuts, right? GDPR is changing that. 4% of global income per breach, right? So many registrars have automatically done this on your behalf. We'll check a few others. Not all of them are like this. WHOIS sec542.com. This one still has, that's sec542.com, which I registered, right? That still has my PO box, et cetera, my phone number, my office, et cetera, et cetera. So they're not all redacted, but many companies are redacted now, and many registrars are redacting on their client's behalf, just doing it automatically, right? I'm sure you could turn that off. So WHOIS, backing up a bit now, it's an old protocol, been around forever. It predates, I believe it predates IP, actually. And it's a way to find out, for our purposes, we still have this, though. I want the DNS servers, right? I want the DNS servers. We still have the DNS servers, which is the most important part for us. But there was other useful information that's now redacted. Like, I have an address I can drive by in the old days and maybe do some more driving. Or put on a FedEx uniform and social engineer my way into that building. You know, it's not hard to do at all. And outside of military environments, it's not hard to get into a building. And I could do some more dialing of these phone numbers. All kinds of things I could do. You know, I can social engineer, I can email someone. Now it's been heavily redacted, but the DNS is still there. The DNS has to be there, and I'll show you this. So the main thing we really wanted was a DNS, which we got. And as you see here, we go back to SANS.org. Yeah, DNS is still there. Lots of stuff is redacted, but DNS is still there. Okay. So definitely still check WHOIS, because it's hit and miss whether there's still more data there than not. In case of SANS gone, sec542.com, it's there. DNS has been around, obviously, a long time as well. Pro tip. You can do a zone transfer via UDP. Most people don't know that. It's going to be a very small zone, though. It's going to be under 512 bytes. So under 512 bytes, you can actually do a zone transfer via UDP. This has come up a couple of times as an important feature. Some firewall admins think blocking TCP port 53 blocks zone transfers. There's a small exception to that rule. Now, how many, is it common to have zones that small? No, it's not, to be fair. But pro tip, if you want to block zone transfers, block the zone transfer. Don't just block TCP port 53. Historically, that was the case. Small transfers with UDP, larger ones TCP, although eDNS is over 4,000 bytes UDP, by the way. That's eDNS. So we're in the age of .anything, .beer, .microsoft, .cisco, .whatever you want. If you have 100-something grand burning a hole in your pocket, you can buy .conrad or something, whatever you want. If you own that intellectual property, you can buy your own TLD now. Zone transfers are quite useful because ultimately we're leading towards getting all the names. I want all the names of all your virtual hosts specifically, right? Virtual hosts, one web server hosting 100 hosts, 100 sites rather, right? I want all 100 sites. Serving to that IP address gets me one site maybe, but there's 99 more there if I only knew their name, right? I need to know their name. So discover the name. DNS is the way I'll do that probably. And if a zone transfer works, that's going to be easy button, right? Now, should you allow zone transfer to the world? No, you should not, right? Zone transfer is designed so secondary servers can slave off primaries. You update one server, and the update rolls out automatically, right, essentially. That's how a zone transfer works. You should only allow zone transfers to your other DNS servers. It is common for companies to allow zone transfers to all internal IPs. This is very dangerous, right? As a pen tester, I break into I get command injection running on your web server. I start running NS lookups or digs, and I can kick off a zone transfer from the web server via command injection. So if you're securing zone transfer by saying all internal IPs, any pen tester who gets on an internal IP now has zone transfers available to them, right? Don't do that either. Only allow zone transfers to your other DNS servers, full stop, right? Zone transfer is the entire database for that domain, or subdomain, right? I would never allow my ISP to handle my DNS, never, never, never. That's a job for me, my company. I've had the argument, what's worse, having your firewall hacked or having your DNS server hacked? Which one's worse? They're both about equally bad, I'd say. That's how critical DNS is. If I own your DNS, PayPal.com can be anywhere I want it to be now. That's super dangerous, right? So I don't want to argue firewall versus DNS, but in the same tier of criticality for not getting owned, right? Manage that yourself. Just to be complete, we have full, which is what we want. Incremental, all changes since serial number X. I want the whole thing, but just to be complete here. They're not available, what do we do? secret-host.sans.org. How do I find that name, right? What if it's not linked anywhere? Like I could go to Google, go to Bing, we'll talk about all this stuff later on, go to DuckDuckGo and find out names that way. But what if a developer has a secret site that's not linked anywhere, right? And Google doesn't know about it. It's some non-obvious string.sans.org. If I knew the name, I could hit that site. I have to know the name. How do I discover the name? Zone transfer is the obvious way. That's probably not going to work. Not initially, right? Maybe on an internal host. So what do? I can do a reverse scan. The problem with the reverse scan is normally it's a PTR record. Normally, where's www.sans.org? That's .10.11.12.13. The PTR one is the reverse. Who's at 10.11.12.13? That's a separate record, though. And PTR records are usually, there's usually only one per IP. So you usually only have one PTR record per IP. Now, you can have multiple, which I found odd and confusing. So if you do a PTR scan, it's worth doing it a few times. Many tools will basically give you round robin the first one they hit. If you have multiple, one IP pointing to multiple hosts, names, which is not common, but can be done. It's legal. It's valid. Many tools will get the first one. And if you ask again, it'll give you the next one, and the next one, and the next one. So do script it to do it 10 times, just to make sure you're getting all of them, right? Now, what pen testing tools call brute force is not what a mathematician would call brute force. A true brute force is A, B, C, D, ... Z, 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 right? It's every combination. If you're brute forcing a true brute force, a pin, it's all zeros to all nines, right? Now, but we call, and this is valid in the industry, what they call a brute force is really a dictionary attack. So I use the term true brute force, which we'll do in here, by the way, later on. We have a lab on a true brute force, which is discovering a directory name. And then we have what they call a brute force, which is really a dictionary attack. Get a word list, create a word list, right? Use a tool like the cool word list, which we'll use and talk about, and guess those names, right? Before we go to the recon tools, the question is there any workaround for the WHOIS redaction? If you own that domain, yes, you can turn that redaction off. So you can go to your whoever it is, GoDaddy or Namecheap or whoever, VeriSign, and turn that off. Usually, most providers allow you to turn it off. They usually turn it on by default, but you can turn it off. But if you don't control the domain, nothing you can do. It's just gone. Yeah. I mean, great point, Jim. So there are historical WHOIS sources out there. So let's find one quick. A lot of it's commercial. Basically, people mined WHOIS for years and saved them in databases. You can get access to that stuff now. Like WHOIS historical data free. So I'm just Googling WHOIS historical data for free. So the historical stuff, if it existed at some point on the internet, yes, that's still out there. So someone harvested that data. But new stuff, you don't control it, nothing you can do. Yeah. So let's talk some DNS recon tools. We've got NSLookup, Dig, Nmap, DNS recon, Metasploit. We're going to talk about each and then do a lab on these in a bit. And the key to DNS, of course, for us is finding all the names. Those names may lead to websites, etc. So NSLookup's been around a long, long time. It was deprecated for a while. Like if you ran NSLookup on Linux 5 years ago, it would say, use of this command is deprecated. Like it was slated for deletion, essentially. They since stopped that. It's now no longer deprecated. It's now supported. It's not as fully featured as Dig is. Dig is better. But it is pretty much universally available on Windows, on Mac, on Linux. Universally pretty much the same syntax. And your web server, if you're doing command injection, NSLookup's probably there. Dig won't be there if it's a Windows host. You could compile Dig. There is a package available for Windows, but it's not there natively. NSLookup will be there. NSLookup will be there on Windows, on Mac, on Linux, and I can use this to do out-of-band, OAST as they said, testing. Blind injection, I can know my commands running by doing an NSLookup to some string dot, say, sec542.com. If I own that DNS server, I'll see the request come in, right? Ping can also be used, but DNS is much more likely to be unfiltered. DNS almost always gets out. DNS may be forwarded, but a DNS forwarder is simply a DNS proxy. We don't call them that, but it is. So if the system can resolve a name, it can send data to the internet, right? And it can tell me my command's working, even if it's a blind injection, meaning I'm not seeing the results, right? Dig is the power tool. Dig can do pretty much anything, look at virtually any record where NSLookup has a subset it can do, right? It's fully featured. It's what you should be using, certainly on Linux. There is a Windows port, but it won't be there natively, of course. Here's some syntax now on various types of lookups. You can specify the server with the IP address or name. Otherwise, it'll use your default server, right? You can do any records, which is a kind of a best of. SOA is start of authority, by the way. That describes the zone. The zone is a database of DNS data for a domain or subdomain, right? And any gives you kind of a top list of A records which map a name to an IP. NS is name server. MX is mail exchanger, your mail server, of course, right? And this is a interesting piece of trivia here. There's a special chaos record which dates back to MIT 1980s, I think, or early 90s. ChaosNet was a 3 megabit Ethernet on cable TV coaxial cables at MIT. That's long dead and buried, but these records still live on. And you can ask a DNS server what version of bind it's running. Bind is the most common DNS software on the internet. All the root name servers run bind, et cetera. Most companies do as well. And it'll tell you the version of bind. Now, it's considered best practice to disable that. No, the only things that resolve version.bind are pen testers and auditors and people like that. No user uses that. That is for testing, auditing, pen testing, whatever. So it's considered best practice to turn that off. And I thought, well, that's boring. Turning it off is boring. I like to use a little bit of offensive countermeasures, throw curveballs at the attackers. So I changed, years ago at my last company, I changed version.bind to be pi to 20 digits. 3.1415926, because I'm a nerd and this amused me briefly. And I said version.bind to be pi to 20 digits to all my DNS servers, and I forgot about it. A year later, we're pen tested. Internal audit hired a pen testing company, didn't have me interview them, just basically hired a bunch of pen testers, gave them the scope, didn't ask me the scope. Remember, I'm the HIPAA security officer and manager of network and security engineering, but I had no say in this, what pen tests they got. An internal audit wanted to save money, so they ordered a server-side test only. No client-side, no social engineering, just plain out server-side, meaning they're attacking the listening services, SMB, DNS, whatever, web, which is a pretty narrow test, and a test I'm unlikely to fail. Not to brag, but perimeter hardening, DMZs, this is straightforward stuff to do. Now, web apps get complicated, but outside of that, securing SMB is easy, block port 445. It's not a hard thing to do, right? So perimeter hardening is in my wheelhouse. They hired a very narrow pen test, meaning I'm going to pass the pen test. I desperately wanted to fail the pen test because I needed more money, needed more funding. And very narrow pen test. And the pen tester calls me, he goes, Eric, we have a critical finding, critical. I'm like, What, I mean, did you log in? Did you get remote code execution? What's critical? Well, it's critical, and we're going to have a meeting on Tuesday with the CIO to discuss the finding. I mean, what's the finding? Well, it's very critical. And he wouldn't tell me the finding. I'm like, what's the finding, dude? See, well, the meeting's Tuesday at 2 o'clock. So I go to the meeting totally blind. I have no idea what they found. I re-pen tested all my stuff. I could find nothing. Not that I'm perfect, not that I can't make a mistake, not that they couldn't have done something I couldn't have, but I just couldn't see how they found it critical, given the scope they had. So we sit down, and they have the whole PowerPoint deck of doom stacked up, and oh, scary things will happen, and we're the saviors, and all that kind of stuff. And here's our critical finding. And it shows version.bind 3.1415926. Like, you're running bind version 3. That date's like 1995. I'm like, and I forgot I'd done that. I forgot, real version of bind was like 9 something. I'm like, I forgot I did that. I'm like, do you see that number? 3.1415926? That's pi to 20 digits. The guy's thinking, what are the odds that randomly version.bind matches pi to 20 digits? Must be a crazy coincidence. I'm like, so I log into the server. I get the version to bind locally. I'm like, I changed it. It's fully patched. I patched it last week. See, I'm logged in. See, I changed the number because I'm a nerd and it was funny to me. And they're like, oh no, staring at their feet. The CIO was like, what's going on here? You know, and they had nothing. They had absolutely nothing. And they had the whole PowerPoint deck of doom. Had they simply said, hey, we found an old version of bind. Like, how am I running bind from 1995? I'm not even sure you can even do that on modern hardware. Like, had they simply told me, not been jerks about it, I could have saved them all the embarrassment, right? 6 months later, I'm doing a pen test in a hospital in Maine, and I do the version.bind thing, because all pen testers do this. We have to, like Geneva Convention, we're required to do this, you know? And it comes back as bind, comma, James bind. That's what it came back as, right? And I thought, I'm not alone in the universe. There's others out there like me, right? So I do a pen test, and I get in, because I also client side, and I get email, and people clicked on things. I owned all the things. And I put my PowerPoint deck together, and I didn't make it a high finding, but I did put a little footnote saying, hello to Mr. Bind. I did put a little footnote, I found your Easter egg, Mr. Bind, you know, hats off to you. So I'm doing my reveal, and the CIO's there, the CISO's there, because I got in, I got medical data, the whole thing, right? There's like a Unix graybeard sitting in the corner, like classic graybeard, big gut, like Unix 97 t-shirt, you know, whole Hollywood Central Casting Unix nerd, right? I'm like, that's James Bind. I know that's James Bind, right? He didn't say anything during the meeting. He just smiled during the meeting because he also wanted to fail a pen test, I'm inferring. And I walked out of the meeting after my reveal was over. I said, are you James Bind? And he gave me a fist bump. I got a fist bump from Mr. Bind. All right, so he's funnier than I am because Bind, James Bind is way more funny than pi to 20 digits. So there you go. Hats off to Mr. Bind. So it is recommended you, as a defender, you turn that off. I like changing things. I like lying to people. I do. Why make the pen tester's job easier? You know, their job's too easy. Let's make it hard. Defense is harder than offense, right? Apparently I offended a pen tester on Twitter, so someone went off of me a bit, not politely, oh, Conrad's dogging on pen testers. I'm like, not dogging on pen testers, it's just their job's too easy. We should make it harder. We should make the cost of attacking harder. We should raise the cost of attacking. And I think their job is too easy. As a pen tester, I can make 100 mistakes and still beat you. As a defender, one mistake might be all it takes to lose. Maybe, you know. It's a very asymmetric threat. I find defense harder than offense, right? Which is why I'm drawn to it. Nmap scripting engine. Nmap used to be a pure port scanner. Now they've expanded all kinds of stuff to the Nmap scripting engine. It uses a language called Lua, a gaming language to write the scripts, yet in a language to learn. Lua is the Portuguese word for moon. Don't know much Lua, but I can read a NSE script and follow it. Carlos Perez is awesome, dark operator, and all kinds of useful brute force scans. He does a ton of great work in the industry. I did a lot of research on PowerShell. I wrote a tool called Deep Blue CLI. I spoke about it at DerbyCon a couple of times, and when I was learning PowerShell hurts my brain still, less now, but PowerShell pipes pass objects, not text, and it took, I unlearned like 25 years of piping knowledge and understanding. It just hurt my brain in a good way. But PowerShell it's actually more powerful than Bash is, certainly. And so I was learning that, and I was Googling like mad, like one of those things like every line of code, like 5 Google searches, 1 line of code. First time I talked to DerbyCon 6, I sent in the CFP. The longest PowerShell script I'd ever written was like 8 lines. And I sent in the CFP and for what would become like a 500-line PowerShell thing, 600 lines or something. And like, you get to think, congratulations, you know, you've been accepted, and DerbyCon's in 6 weeks. So you start doing the happy dance, like, oh, I gotta write this thing. What have I done to myself, right? So I find giving myself a project with a deadline that I have to commit to, that makes me learn. So yeah, 5 Google searches, 1 line of code, 6 Google searches, 1 line of code, and many of my Google searches led to him. He did all kinds of great stuff, right? So he's awesome. Also DNS Recon, of course. Here's some output now. See, it's doing the version.bind thing here. It's doing start of authority, it describes the zone. NS is name server, text records, MX is mail exchanger. Text is pretty much free-form text. It's often used for like spam blocking and SPF, which is a form of spam blocking, DKIM, things like that. Many web app pen testers don't pay much attention to Metasploit because Metasploit historically wasn't geared towards web app pen testing. They've added a whole bunch of stuff to it though, and it is very useful for this. And it can be, you'll see like, I'm facing like some point in the future, I may be hinting for say day 6, I don't know. I'm facing a Joomla server. I've never hacked Joomla before. I'm like, what do? How do I hack Joomla? And you go on Metasploit, you go search Joomla, it's got like 5 exploits, and you try them in order from most recent to least recent. That's what I do. Number 4 works. Great, So it can be very useful that way to hack stuff that I wouldn't be able to hack otherwise. All right, everyone, let's do a lab 1.1 DNS harvesting. So did you hear me say previously, you're going to open up Firefox. If you see this little warning banner up here that I discussed, that means you haven't run this command, so go ahead and do so. I'm going to do so again. It's harmless to run as many times as you want. The sudo password is security542. I've already run the command, so there aren't any real updates, so I'd get less output. If you see more output, it means we got updates, right? And then I'll go to lab 542.1, DNS harvesting. And again, as I said previously, you've got the no hints and full hints, but I'm going to go through now in the full reveal now. So hit solution, do a dig, and I'll walk through this dig now. I'll type clear. And so here's the command I typed. Dig for the sec542.org zone -type any. Any is like kind of a best of, most common records you get. Start of authority describes the DNS zone itself. And so the host name is ns1.sec542.org of the DNS server. The admin's email address is admin@sec542.org. Now I know it says admin.sec542.org, but in reality, that's the format for showing an email address. You want to email someone about their zone, you can email them there. And we got some other records down here, such as the A record, 542.org points to 10.42.42.42. The NS or name server record is NS1, as we learned previously up here. The mail exchanger, MX, is mail.sec542.net. We have a text record now of, just as a little kind of in-joke, so long and thanks for all the fish. Sec542 uses a Hitchhiker's Guide to the Galaxy theme. 42 is the answer to life, the universe, and everything. If you've read the novels or heard the radio plays or seen the movie, you probably know that. An additional section, a few more records. ns1.sec542.net's IP address is that, which is the same as sec542.org. Same with mail.sec542.net. Now let's try the same thing for .net, sec542.net. And similar look here. I get a few less records here, no text record, for example. Now let's go down into the next section now. Attempt a zone transfer. Now, spoiler alert, the first one's going to work, the second one's going to fail by design. So sec542.org is allowing zone transfers. You shouldn't allow zone transfers to the world. This is obviously inside a VM and it's contained within your VM, so it's not dangerous. But if you allow anyone on the internet to download your zone, you're allowing anyone on the internet to see all your records, which can be quite dangerous. Because as later on we'll start doing virtual host discovery, I have to know the name to get there. Like the only way I can find the site ajax.sec542.org is to know that name. If I don't know that name, I can't reach that virtual host if ajax.sec542.org is a virtual host. So we see, previously we did -t any, we saw some of these records, but now zone transfer, we're seeing all the records, right? The entire zone. And as a web app pen tester, I'm going to every single one of these names. Now we'll try .net, and it's going to fail by design because zone transfers are turned off to the world, as they should be. And since I'm not a DNS server, it's not allowing that zone transfer. All right, let's go to the next section. And we've got some DNS recon now. I'm going to do another zone transfer. We can do, well, same thing, we're using a different tool. This is zone transfer using DNS Recon. And you can also use mmap to do the same thing. I like showing you multiple tools for doing the same thing. I'll let that run in the background while I go to the next. That'll take a little while to run. I like showing multiple tools for the same effect. That way you get handier with more tools. Makes you a better pen tester. Now let's do a DNS brute script. We're going to open a new terminal while the other one's still running. Now, as you heard me say in lecture, brute force is not a true brute force. This is really a dictionary attack. Now, that term brute force is how it's used in our industry. And before we do that, let's see if this one finished. Yeah, this one finished. Let's go back to the previous mmap scan since it's done now. It found ports 22 and 53 were open. It did a zone transfer, as we told it to here, right there. And it also found additional ports open as well. So it did an mmap scan of the top 1,000 ports, and you can probably see up here. And 995 closed ports, 5 open. I'm inferring from that. You can have mmap scan every single last port. You do -P0-65535. That'll get all ports. There is a -P- flag. That actually skips port 0. I'm not sure why. It does 1 through 65535, at least last time I checked, last version I checked. So it does a port scan of the top 1,000 ports, and since we told it to, it did a zone transfer right there. And again, we have 22, 53, 80, 443, and 8,000 open. And as a pen tester, web app pen tester, you want to make sure you check that one out too. That's actually our wiki, but I'd check it out. All right, so now we did a brute force. Again, brute force is a bit misleading. It's a dictionary attack. And we found test.sec542.net, ns1.sec542.net, mail, www, and FTP. Again, the term brute force, we're using it accurately for the way our industry uses it. Later on in class, we'll do an actual true brute force of a directory name from AAA to ZZZ and every combination in between. That's a true brute force. A regular brute force in this world, pen testing world, means dictionary attack in the web app pen testing world. All right, so we did that. Now we'll do a DNS brute force using DNS Recon. Let's try that out. And it found, you can see already, it found another host. cus42.sec542.net, which is going to feature prominently in 3 labs. This lab here, later on we'll do a brute force attack to discover a hidden directory. And then we'll find some MediaWiki software there, and then on day 5 we'll actually hack that software and break into it. So a 3-part lab, starting with the discovery of that name. So some overlap with the previous list and some new ones as well. The reason why is DNS Recon uses a different word list, a longer word list. We show you a few ways to run, and you can feed word lists into DNS Recon. You can change rather down here. Here you can make mmap actually use DNS Recon's list and get the same output down here. You can actually run that command. So it got different results simply because it was using a different word list. And here's mmap with the longer word list. It also finds that host. Finally, we use Metasploit. So up here, MSF console. So we'll start MSF console. It'll take a little while to start up. And you always get ASCII art when MSF console starts up. And it's random every time you get it. If you enjoy ASCII art, you can type banner. So I got the Metasploit cow there. You can type banner. You can get different artwork every time if you like. If you're an ASCII art fan, as I am. There's a Metasploit cow again, et cetera, et cetera. All right, so now we'll run the enum DNS command. And bang. And so what's nice about copy-paste is normally you have to type that in by hand one by one. Of course, you can still do that if you'd like, but it's a lot easier to hit that button. But some students want to learn like the finger memory, the muscle memory of doing it hands-on. That's fine too. Your call. It is a bit faster, of course, to copy-paste. So we used the auxiliary module gather enum DNS. We set our domain as sec542.net. We set enum reverse to be true, our IP range, and then we scanned. And it did a zone transfer, attempted to, which failed. It queried CNAMEs, NS records, things like that. And these pointer records are the reverse scan, where normally you resolve a name to an IP. Pointer record scans resolve an IP to a name. All right, and that wraps up Lab 1. Thank you.